Welcome to the Brilliant Academy.
Oh, now first of all, we just come across with the definition of motion, what the motion is all about. Okay, now we just first of all we just go with the definition. As per the definition of motion, an object is said to be in motion when it changes its position with respect to time. Now, what is the meaning of how you can say that something is in the motion? For example, I just take an example as such. You are standing on a platform, on a railway platform. You are at a stationary position, and all of a sudden what happens, train comes and crosses the platform. In that situation you are stationary. As the time is progressing, the object is moving. The object, I mean to say that this is the train is moving. So the train is moving its position with respect to time, with the reference of any stationary object which you are. So that is what the definition of motion. Okay, now uh, this is one of the simplest definition of the motion is all about. uh, right now we just come across what are the physical quantities. We just that was the first one that you have with you. Now we just come across with the second one. This is called physical quantities, because we have to understand physical quantities, because we have to understand about the scalar quantity and vector quantities. So in that situation we need to know about it. Now you must be wondering that what the physical quantities all about. See that all quantities which measure your physical world, all quantities which measure our physical world are called physical quantities. Now, if you just take the examples, I mean, physical quantities, there must be some physical quantities which the example which we can give. For example, mass, weight, distance, displacement, speed, velocity. These are all the examples of the physical quantities. These physical quantities are responsible for measuring your physical world, how the things are going on, how what is the how heavy is the object. These all are the physical quantities. So right now for the examples, I just can say that the examples are as such: mass, weight, speed, velocity, etc. Okay, so right now this is what we have. This one, the physical quantities. We understood about the physical quantities. Now, whenever you are talking about the physical quantities, the physical quantities are basically okay. Now, we will. I mean, the physical quantities we we get to know about the physical quantities. The physical quantities basically we divide the physical quantities in two categories. Now, physical quantities can be divided into two categories. We just have two categories of them. One is called the scalar quantities, and another is called the vector one. Okay, now we will discuss uh, what is further the definition of scalar quantity and vector quantity. We have to just see this one. Now, first of all, we just start with the scalar quantity. Now, regarding your scalar quantities basically are those quantities which require only magnitude. I mean, any quantity, any physical quantity can be completely described with the help of magnitude and as well as direction. So, I mean, two parameters which are required for the physical quantity to be completely described. So whenever you are talking about scalar quantity, now the scalar quantity is such a quantity which can be completely described by magnitude only. That means there is no need of direction at all. There is no need of direction. Now I just take the example of it. You can take the example as such. The example you take the example. This is called mass. This is called distance. They are basically the the examples of scalar quantity. Scalar quantity in which only the magnitude is enough to describe it. Mass, for example, if you just say that what the mass of an object is, for example, 2 kg is the mass of it. Now, for example, distance use it 2 meter is the distance. So there is no any need of direction to describe it. So this is what we have, the scalar quantity. So once again, a scalar quantity which can be a quantity which can be completely described by magnitude only, they should be called the scalar quantities. A few examples that we have with us, that is mass, distance, speed, energy. These are all the examples of your scalar quantity. Now we just come across with that one, with the vector quantity. Now, a quantity which can be completely described with the help of magnitude and direction both. Okay. Now, first of all, I just go with the examples. I just make it out very clear that what are the examples are. Now, for example, you have the example as displacement is the example. Velocity is the example. Okay, these basically require direction. Direction is absolutely very important. For example, if you just say that displacement, this is 2 meter towards north. Okay, so the direction is always be required for the vector quantities. So this is what we have. This is for the scalar quantity and vector quantity. Now we just move on to the next topic. This is called distance and displacement. Okay, as in the previously we just discussed about the scalar quantity and vector quantity. The topic now, right now we have the topic. This is called distance and displacement. Just try to see that the distance itself a scalar quantity, whereas you talk about displacement is a vector quantity. Now we will have a difference of these two terms, these two physical quantity. We will also see that one. So first of all, we just go with the definition of what the distance is all about. Now see that. This kind of a definition that you have must studied up to your lower classes. So right now we just come across with the definition distance and distance. First of all, we just go with the distance definition. Distance, it is defined as the actual path traveled by an object between its initial and final position. Its final position. Okay, so right now that means it means that the actual path, the actual path which is traveled by an object between initial and final position. I just take a very simple example. You come to school by bus. Okay, so initial position is your bus stop where you board. Now your final destination is obviously is your school where you board down. So right now the actual path which is traveled by the bus, okay, that not necessarily be the shortest one. It takes all the street, all the roads and this all. So that is the actual path which is traveled by the bus. That should be called the distance. Right now I just take an example. For example, I just take by a diagram. We just try to understand what the definition is all about. This one, for example, this is your bus stop from where you board on. Okay, now I just call it a position A. Now your bus is taking this route, this kind of a route. For example, this kind of a route is taken by your, and you board down here. This is your school. Okay, this is your school and this is your home. Okay, now this the whole, just try to see that the whole path which is traveled by you, that should be called the distance. Okay, now in that situation, in the same way, we just come across with the definition of displacement also. And with this example, we just also understand what the meaning of the displacement is all about. First of all, I just go with the definition part of it. It is defined as the shortest distance or the shortest path. The shortest path traveled by the object, okay, between its initial and final position. For example, if I just take a very the example that we are taking above, I just make it out very clear to you what the what would be the displacement in this condition and this example. In this example, what would be the displacement is. Now for this one, we have to just take a shortest path. Okay, now we just take the shortest path of the shortest distance has been taken right now here. The shortest distance has been taken. Now this should be counted as a displacement. We just call it a displacement. Now this example in which you started from home your bus took a route and thereafter it reached the school. That is the distance, that is the proper distance, the actual path which is traveled by the object. Now whenever you talk about the displacement, that should be called the shorter distance. Now this is the shortest distance between the school and your home. Now just try to see that it's very very important that there must be a direction should be given. I mean, if you just want to see that where you have to see it, I mean, if you just want to see what is the shorter distance between A and B, so you need to define it by the direction also. If I say that, for example, I just come across with that one. First of all, I just uh, try to give you the symbol for distance. The symbol for distance, symbol. Usually we take symbol as S, whereas we take uh, its symbol as S dash, uh, S arrowhead. S arrowhead is the symbol. This arrowhead is nothing else than it's showing the vector quantity, because it's a vector quantity. So direction is very very important. So if in this condition, I will just say that, for example, the whole path or the whole distance which is traveled by, for example, I take my example. I just come to school. Uh, I just from my home and to school. It takes almost 19.2 kilometer. Okay, but I've just not seen what the displacement is all about. So in that situation I say that this is the displacement. So displacement could have been, for example, 11 kilometer. Now it's very very important, the direction must be given. So in that situation you need to give the direction. For example, this is the direction chart you have. For example, this is the direction chart we have. Okay, this is north, this is south, this is your east, this is your west. Now for example, if I just put this direction chart or a direction bar here, so what we will see that we are moving. For example, if I just move in this direction, so in that situation I'm just moving towards east. So in that situation we just should write that 11 kilometer towards east. Okay, so that is what the basic difference between the distance and displacement. Distance itself is a scalar quantity and is the actual path which is traveled by an object. Whereas displacement you talk about, the displacement is nothing else than the shorter distance between the two positions, initial and final position that you have of the object, and the shorter distance should be called as a displacement. So right now we just came across with the both the definition. We just happen to be knowing about the major difference between them. Distance is a scalar quantity, whereas displacement is a vector quantity. And this is what we have for this one. This is for distance and displacement. Now we just move on to the next one. Okay, when we just see that the difference, what is the difference between the distance and displacement? The first thing is that we have with us, the distance is a scalar quantity. Just try to see that this is a scalar quantity. Okay, whereas if you just talk about the displacement, it's a vector quantity. Okay, a scalar quantity which is only having magnitude, whereas your vector quantity, both magnitude as well as direction, both are required. So we just have given the both of the for the magnitude and direction and the both other conditions. Now the second point which should be the difference between the distance and displacement. Whenever you get this kind of a question in your examination, a 2 point difference between the distance and displacement, in that situation this is the first point that you have with you. And when you talk about the second difference, the second difference is your distance cannot be negative. Just see that the distance traveled by an object in motion can never be negative. Your distance can never be negative, but the displacement can be positive, 0, or negative oval. I mean, I would just take a few of the examples. I take some of the numericals in which you will just get to know that how the displacement happened to be 0. Okay, so this is the basic difference between the distance and displacement. Okay, now we move on to the numericals. Now we just move on to the numerical portion on distance and displacement. We just come across with the first question. I read out the first question for you first of all. A body travels a distance of 15 meter from A to B and then moves a distance of 20 meter at right angles through AB. Calculate the distance traveled and the displacement. Now, if just you come across with this question, particularly the direction, the very particular direction is not given here. So we have a choice. We can make out our own direction, and that way we just explain what the displacement is all about. Okay. So now I just first of all we just once again we just see the question from A to B. The object moves 15 meter. So first of all we just take. This is position A, for example. This is position A. Okay. Now, from here, 15 meter is a distance. For example, this is the 15 meter is a distance which has been taken over there. Okay. And now it reaches to the position B. Okay. From A to B and then moves a distance of right angle to B. Now, okay. Now this should be called as B. Once again it moves towards at the right angle. I mean, it can move either of the sides. It can move here, it can move here. Now for example, if it moves, okay, now this is the position C right now. Okay, now we just make it out clear what the direction is all about. This is the direction. First of all, I just make it out a chart of direction also. Okay, now this is the direction chart. We have the direction chart. For example, this is your north, this is your south, this is your east, this is your west. Now the very first condition is there. It moves. So for this example, the object moving is from A to B and towards south it moves, and thereafter it moves towards east. So that would be your 15 meter. This is your 15 meter and this is your 20 meter. Now first of all we just calculate what the distance is all about. Okay, now first of all the distance. Okay, now the distance as that is equals to your AB plus your BC, and that is equals to 15 plus your 20, and obviously that should be your 35 meter. Okay, so this is the distance that we have calculated. Since it is a scalar quantity, it does not require any direction, so there is no need of direction. It is completely described right now. The distance is completely described as 35 meter. Okay, now we just calculate what the displacement is all about. Now displacement is nothing else than the shortest distance between A and C. Now it should be a shorter distance between A and C. That should be counted as. Now we just make it out very clear here. Okay, now this is what we have. This is the shorter distance between A and C. Now direction is wise. Now see that A should be called the initial position because it started from A, so that is initial, and that should be called final. So very important thing is that the object moved from the initial to final, so the direction should be counted is as this one. So this is the direction. This is the direction that we are just able to see that here. Okay, now Now displacement, which is nothing else than S arrowhead. Okay, now that should be the shorter distance. Now see that this should be counted as your right angle triangle by the theorem which is called the Pythagoras theorem. In that situation we must be having this one. So we just apply the Pythagoras theorem and find AC. Now our AC is nothing else a hypotenuse. This is a hypotenuse. Hypotenuse square is equals to your AB square plus your BC square. Okay. Now by applying this one, we have this one. This is as a 15 square plus 20 square, and that is equals to 225 plus 400, which is nothing else than your 6 to 5. Okay, now in that situation your AC must be root of 6 to 5, and that is equals to 25 meter. Now just try to see that your displacement is coming out to be less than your distance. Now distance was your 35 meter, whereas you are talking about the displacement is 25 meter. It's less than that. Okay, so this is also I mean you can make out one bottom line also, that the displacement can never be more than your distance. It can be equal, but it cannot be in any condition, it cannot be more than distance. So now the displacement which is coming here, that is 25 meter, and the distance is 35 meter. Now a very important thing is that the direction must be there. Now just try to see that the direction. Now if I just extra plot uh, this direction chart to here, it should be showing this direction. Okay, and this is nothing else than southeast. So your displacement is 25 meter towards southeast. Now it is completely defined. Displacement is completely defined. First we defined the distance, second we defined the distance. With the help of numerical, we just make out the difference between the distance and displacement. Displacement is nothing else than the shorter distance. Okay, and the direction is very important because it's a vector quantity. Whenever you are talking about distance, distance is a scalar quantity. It is the actual path. And uh, we also concluded from the discussion that the displacement can never be more than your distance. Okay, now we just move on to the next numerical. Okay, now we have the next question that is called first of all, I just read the question for you right now. This is: a particle is moving in a circle with a diameter of 98 meter. Calculate the distance covered and displacement when it completes 2.5 revolutions. Okay, we just try to understand for what the question is first of all about. This is what we have. This is what the diameter that we are having with us. This is 98 meter. Okay, now I show it you with the help of a diagram. Now we just see that. Okay, now for example, this is a circle that you are having with you. Okay, now if I suppose that the because the particle has to move around the circle, in that situation I just arbitrarily I just take any point on it. For example, I just take this one. This is the point A. This is my initial position would be. Okay, now I just make it out clear. Now the diameter that we have to take, this is the diameter. Okay, now this is the diameter that we have with us. This is the diameter. Okay, so now for example, now we just take out how it is moving. For example, it is moving in this way. Okay, it's moving in this way. This is it is moving. Now this is the direction chart that we can have with us. This is north, this is south, this is east, this is west. Okay, now it's moving in this way. Now this is it starts from me. Now it moves. This is the first round. Now it moves to the second round. Now this is moved to the 1, 2.5 round. Now this is would be the final position. That should be called the final position, for example B. Okay, so in that situation, this is we just out make it out very clear here. This is the initial and this is the final one. Okay, this is the final one, and it moves in the direction that is with the that would be the direction of it. Now we just come across with the solution of this question. Now see that first of all we just find out the distance. So as per the definition of distance, as you know, that is the actual path which is traveled by it, and the actual path would be now regarding if you just talk about it's one revolution, one complete revolution, as you know about. Okay, that should be given by the circumference of the circle, and we know that the circumference of the circle, that is 2 pi r. Okay, now the total distance should be what? This is 2.5 multiply 2 pi r. That is 2.5 revolutions are there, and for one revolution 2 pi r is there. Now first of all we just find out what the r is. Now r is nothing else than this is your 98 divided by 2, which is equals to 49 meter. Okay, now the distance is equals to this is 5 by 2. Okay, multiply 2 multiply 22 by 7 and multiply 49. Okay, this is cancel, this is cancel, this is cancel, this is cancel. Now we have nothing else than this is 5 multiply 22 multiply 7, and which is equals to 110 multiply 7, and which is equals to 770 meter. Okay, so now this is the calculation for the distance. This we just found the distance. For the distance is all about right now. 2.5 revolutions are there. The diameter is 98 meter. Radius would be 49 meter. The distance would be 2.5. 2.5 multiply 2 pi r. So as per the calculation, we are getting 770 meter as the uh, distance. Now we just move on to find out how the displacement would be there. Regarding displacement, just try to see that what we have with us right now. See that was the initial. A was the initial position. Now this is the first round. This is the second round. Now this is 2.5 round. Now the position. Now the object has reached to what? Reached to B position. Now the shortest distance between A and B would be nothing else than the diameter AB. So the displacement is nothing else than your AB, diameter AB, and that is nothing else than your 98 meter. And you just see that direction, what the direction is all about. Okay, now this is the direction towards east, that is going towards east. So now this is what we have. So we just write this is towards east, right? So in this way, we calculated both the distance and displacement if an object is which is moving in a circular path having diameter of 98 meter, and it took 2.5 revolutions. So this is the way this kind of questions are done. Now we just move on to the next question. Okay, now you just see that this question, this is our third question that we have with us right now. This is basically the question which is given in the textbook also. We just try to see what the question is all about. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Now, what will be the magnitude of displacement of the farmer at the end of the 2 minute and 20 seconds? That is the question we have in front of us. Now, first of all, we just have a figure. We just make it out a figure here. Uh, Basically in this question, in most of the books that you will see that only one part is given, otherwise it is having it has two cases. So I just make it out two diagrams here. Okay, now this is the first diagram that we have with us. We have just two cases here. I just make it out clear how the two cases are there. Now we just come across with the case number 1. Okay, now for example, the farmer. For example, this is the initial position from the farmer moves. Okay. Now, as per the question, what is that? The boundary is how much? This is 10-meter boundary. Now, what he does, he is moving. Now, for example, he moves in this direction. Okay. So this is 10 meter. It is a square. All are 10 meter. So the one distance is covered is exactly in 40 seconds. I mean, around the square, in 40 seconds, he moves 40 meter. That is the first thing that we have to understand about this one. Right now, what is happening over there? This is what we have. This is in 40 seconds, one complete revolution is there. So in that situation, what is that? This is 40 meter is covered in 40 seconds. So in very precisely in 10 seconds, 10 meter would be covered. Now, as for the timing, what the timing is 2 minutes and 20 seconds are there. Now, 2 minutes, this is what we have. This is 2 minute. This is 2 minute is 2 into 60 plus what? Plus your 20, and that is equals to your. This is the time. Okay, so that would be your 140 seconds. As per this, uh, equivalence, what we have, 140 seconds means 140 meter is covered. Now, how the 140 meter would be there? This is one revolution. This is about 40. Okay, so what we do, we just find out the number of okay, the number of revolutions. Okay, that would be upon 40. This is your 7. This is your 2 and 3.5. That means he moves absolutely 3.5 times around this square boundary. Now, we just see that, just try to see. Now that this is your one complete, this is your second, this is your third. Now, this is your 3.5. Now this object reaches this position. This is the B position there. In that situation, the displacement would be the shorter distance between A and B. So now this is the shorter distance. Okay, this should be the shorter distance, and this is your direction. The direction is there. We just also have a direction chart here. This is north, south, east and west. Now this position is nothing else than southeast. Okay, so now displacement is nothing else than this one, the diagonal of it. So this is your right angle triangle. In that situation, Pythagoras theorem can be applied. This is the B. For example, you take it C. Now your AB square is equals to your AC square plus your BC square. Okay. Now that is 10 square plus 10 square. This is nothing else than your 200. Okay. Now AB is equals to this is root of 2 that is equals to 2 root 10. So that is what we have, and the direction that you will see, okay, the direction is northeast. Okay, so in this way, this is done. This is the displacement that you have just found. This one, in that case, This is the case number 1 that we have just discussed. Now we just discuss the case number 2. In second case, what we have now, for example, your object. Now once again, we just have a diagram. Now this is the square that we have with us. This is your A. Okay, now we have to just look at this thing. Okay. Now, for example, if we just say that the farmer himself is moving from here, that is the middle of it. I mean, it's not moving. It's not moving from the corner of the field. Now it is moving in the middle of any site. Okay. Now from here, first of all, how much revolutions will be there? That is 3.5. Now we just see that this is your 1, this is your 2, this is your 3. Now this is 3.5. So that will be your final position. Now regarding this one, just see that this is what we have. This is the shorter distance that we have with us. Okay. Once again, this is the shorter distance that we have with us. This is the shorter distance we calculated here. Now the shorter distance is nothing else than the shorter distance that we have with us. This is the side equal to the side of this one, the square. This is your 10 meter. So obviously that would be also 10 meter. So the displacement is nothing else than 10 meter. And direction that you want to see that this is towards south. Okay, so right now we just happen to be knowing about the question which we have. This is the NCRT question as well. So in this situation, we have just seen the two cases, how we have just calculated the displacement and how the direction was very important. So that was what we have. Goodbye for now. In the next video, I will just bring out other topics of 9th class also. So goodbye for now. We will meet in the next video regarding the new topic that we have with us. This is called speed and velocity. So just keep watching it.
The Brilliant Academy announces. Join online classes. Convert the disadvantage into advantage. Special features. 1. Use the latest technology. 2. From the comfort of home. 3. Proper syllabus coverage. 4. Proper notes provision. 5. Online test through MS Form. Subjects taught. Mathematics from Class 8 to 12. Science from Class 8 to 10. Contact 958294637 7011845089.